Hello everyone, and I'd like to welcome you CCNA routing and switching. Let's begin. Today we will discuss and understand the concept of routing. So routing concept can be classified into three categories. First we need to understand the path determination. Second one, packet forwarding methods. Third one, basic configuration of router to verify the static routes. Today we will see the path determination, packet forwarding and basic configuration one by one. First, path determination. What is path determination? If a router receives the packets on the one interface, then it determines to forward the best path. It is known as routing. It may be directly connected or remotely connected. If your packet is arrived to the router, then based on the routing table, it can be sent to remotely connected network or internet. There are two types of routes. One is the static route, another one is the dynamic route. So static route is nothing but we need to configure manually by network admin to building the routing table. So it is to improve the security and control of resources. It can use less bandwidth than the dynamic routing protocol. So mainly CPU cycle is not utilized for the static routing. But dynamic routing, it can utilize the CPU cycle to understand the remote networks based on the algorithm. The n number of dynamic routing algorithm is available in the real-time mode. We can see one by one. Next one is the path forwarding mechanism. For example, path forwarding mechanism. Here, user can sit in this place. So, what is the process of forwarding mechanism? If the data link frame, that is the only MAC address which contain the IP address, it arrive the ingress interface. Ingress interface means that is the inside to outside. The router assumes the destination IP address in the packet header. Packet header, it contains the source address and destination address. Then it can match the routing table. Then it can forward to the egress interface. Egress interface is nothing but outgoing interface. Ingress interface is nothing but incoming interface. It analyzes the every packet of the IP address to analyze where we can forward the packet to the corresponding destination. It may be directly connected or remotely connected. Packet forwarding mechanism contains the three types of categories. We can see one by one. First one is the process switching. Just a minute. First one is the process switching. So process switching is nothing but it is the old mechanism. By default, Cisco router, if any users coming to that router, it check the every packet in the routing table where we can forward. So it can utilize the more CPU cycle to forward the every packet. So it need more CPU cycle. It is the old mechanism, old method. So every time it can understand the routing information from control plane. What is the difference between the control plane and data plane? So control plane, it can update the routing table, routing information. Data plane is nothing but it simply forward the data traffic from source to destination. Forward the data traffic. Most of the routing information learned from control plane only. Second one, fast switching. It is the second generation of the packet forwarding mechanism. It can store the routing information in the cache in the router for a particular time. Fast forward cache. It is less CPU cycle compared to the process switching. And the last one is the Cisco Express forwarding. Where we can, yeah. Third one is the Cisco. Now most of the router is using Cisco Express forwarding. The most and recent default Cisco IO is packet forwarding mechanism. It builds the forward information base and adjacency table. Forward information base is nothing but it contains the routing information of the directly connected network or remotely landed networks. So based on the destination, it can forward the data traffic. It uses only the data plane. Because forward information base contains all the routing information, it does not use the CPU cycle. Now, recent technology is using the Cisco Express forwarding mechanism. It contains the forward information base as well as the adjacency table. Now we go to the configuration to verify the routes. Here I need to take the two routers. And two switches. For different device, I need to connect the straight through cable. Mostly you can follow the bottom to top approach. We can sort the issue easily. while comparing to the top-down approach. And then add the serial adapter, and after that I can turn on the device. .192 168.10.1 network, 20 dot network and 30 dot network. Go to the router. I can give in command no. Enable config terminal interface G0/0. IP address 192.168.10.1 followed by no shutdown command. Now it is turned on. Interface serial number 0/0, IP address 192.168.30.1 followed by subnets. As well as I need to configure the right side also. Enable config terminal interface G0/0, IP address 192.168.20.1 followed by but the serial interface, both side will need to up the interface. It can turn on the, so left side we need configure the 30.1, here 30.2. Yeah, I configured only the IP address 192.168.10.1 for the interface G0/0, 192.168.30.1 for the serial interface 0/0/0. Same ways right side 192.168.20.1 for gigabit Ethernet 0/0, then 192.168.30.2. So how many networks in this scenario? You can see, so this is the one network, this is the another network, this is the another network. For the router R1, what are the networks are directly connected? This one, it is connected left side, then it is connected right side. For R2 router, this network is connected right side, this network connected the left side. Here 1, 2, 3. Then for R1 router, directly connected networks are 1, 2. R2 router 2, 3. For remote networks, it is the directly connected. For remote networks, third network. It may be some country or wherever it may be. Here 1. So R1 remote networks are third network, then R2 is the remote network of 1. Now verify the routing table. Go to the global privilege mode, so IP root. Here L is the local, C is the connected, S is the static, R is the read, it is the dynamic networks, we can see later. Then this one is the candidate default. So it is the two networks are directly connected, first one, then second one. C is the directly connected network. It can represent the network address. Then L is the interface IP address. We can configure IP address. Likewise, 30.0 is the network address. Then 30.1 is the interface IP address for the which interface? Serial interface. This one is the gigabit Ethernet interface. Next. So IP interface brief. Here you can see gigabit Ethernet interface 0/0. Then IP address is 10.1. Then status is up. Protocol is up. Likewise, serial interface 0/0, 192.168.30.1, then status up, then protocols up. So IP interface, it can detail show the information. What are the commands? So gigabit Ethernet 0/0 is up, line protocol is up, IP address. Then broadcast address, MTU, maximum transmission unit. So there is no ACL between the ingoing interface and the outgoing interface. Here maximum transmission unit is 1500. How we need to configure the default static route? IP route. Here you can put the question mark, it can show the so outgoing interface. We can configure serial number. Just a minute. Yeah. Like this, you can see this routing table. You can configure the serial interface, that is outgoing interface, serial number 0/0/1, or we can configure the IP address 192.168.30.2. Then save the configuration. Here you can see this is the default static route, candidate default. So what is the candidate default route? So if we can know 192.168.10.0, 30.0, then 20.0. For example, 172.16.1.0, 2.0, then a number of networks are available in the real-time world. All the traffic go to this interface. This is the default static route. So it can reference any network coming from unknown IP address. It can by default forward the traffic corresponding this interface. Now we check the 192 for the remote network 10.1. It does not know where the traffic is going, which interface. So we need to configure the static route or default static route to go in that interface. The command is IP route 0.0.0, 0.0.0, 192.168.30.1. Now we check ping followed by the remote network address. You can see the packet delivery rate, success rate 100%. Then additional commands. So running include. Include means it contains the what are the characters we have need to types. So router is not route. It contains the route IP route 0.0.0.0.0.0, then exit interface. Then begin. Begin is nothing but starting from the route command start from. You can see begin means it starting from what are the routes. So under the what are the commands is available. Or exclude. Exclude means without this command, these characters. It does not contains the route information. Then section. I hope you can understand the routing concept, and I want to thank you for watching this video. Please like and subscribe to join the adventure knowledge journey in network jungle. Let's see the next video.